Today we're beginning our unit on three-dimensional figures. We're going to start by introducing different types of three-dimensional figures that we can have. So we're going to discuss different classifications for them and different ways that we can look at these figures. So we're going to start by discussing what a polyhedron is. So a polyhedron is pretty much what happens if you take a polygon and you start connecting different polygons together to create a three-dimensional object. So it is created out of only polygons. So remember, polygons have to have straight lines, no crossover sections, no curved edges. So these are the triangles, quadrilaterals, pentagons, hexagons, octagons, nonagons, decagons. So a polyhedron is made up of all these polygons. Each of those polygons is called a face. So each side of our shape is called a face. So in this rectangular prism that we have here, each of those rectangular sides are faces. An edge is where two faces or two of the polygons meet. So this right here would be one of our edges, and that's a little hard to see. So we'll make it a little bit bigger. So that's one of our edges. And then a vertex is where your edges intersect. So they are these corners right here. So I've got my edge, I have a vertex, and then this is a face. All right. When we're talking about more than one polyhedron, we will either say polyhedrons or polyhedra. Now these two objects down here, these are not polyhedra, or they're not polyhedrons for one very particular reason. Both of these have faces that are not polygons. So this right here, this is a cylinder, and its two bases, which are special types of faces, which we'll talk about in just a second, are circles. And in our cone, we have a base that is a circle. Circles, remember, are not polygons. So these are not polyhedron. So we are going to be talking a lot about cylinders and cones, but they are not polyhedrons. So we're going to focus on just some polyhedrons right now. Two types of polyhedrons are our prisms and pyramids. So a prism is made out of all of these polygon faces, but two of those faces are special, and we call those two faces the bases. Oops. We're going to make that just a little smaller. And those two bases are two shapes that are identical, they're congruent to each other, and they are parallel. Every other face is what we call our lateral faces. And those faces need to be made out of rectangles. No matter what shape your base is, your lateral faces are rectangles. So this right here is what we would call a pentagonal prism. And it's called a pentagonal prism because the bases are pentagons. So my two bases, those are pentagons. They are identical to each other. They are parallel to each other. Those two bases will never intersect. All of the other faces, these other sides here, you'll see are rectangles. Oops. They are all rectangles. And so these are what we call the faces or the lateral faces. Lateral meaning side. So all of these rectangles going around are the faces. The lateral faces, and then the two pentagons are your bases. So prisms have to have two bases. They have a top and a bottom. Now, pyramids, on the other hand, think about the pyramids that are in Egypt or the ones that are in South America. Pyramids only have one base. So this right here is what we would call our pentagonal pyramid, because the base is a pentagon, but that's the only base. If I go up from my base, I don't reach another pentagon, but rather all of my sides, all of those lateral faces come to a single vertex, a single point up at the top. So instead of having two bases, I only have one. So one base. And then all of my other faces, my lateral faces, are triangles. So in a prism, all of the lateral faces are rectangles. In a pyramid, all of your lateral faces are triangles because they all reach one single point up at the top. When we name our pyramids and our prisms, we name them off of the shape of our bases. So we've already seen the pentagonal prism, but this right here is what we would either call a rectangular prism, or if this is indeed a square, we would call it a square prism. Now, rectangular prisms can be a little tricky because your bases are rectangles, but so are all of your other faces. So sometimes it's hard to distinguish which side is your base. Typically for rectangular prisms, they sit on the base. All of our other prisms, pentagonal prisms, triangular prisms, they can be laying on their sides. And we're going to get into more detail with that when we talk about surface area and volume and all of those wonderful things. But prisms and pyramids are named off of the shape of their base. So we've got our pentagonal pyramid. We also have a rectangular, or if this is indeed a square, we would call that a square pyramid. Okay, square pyramids, rectangular pyramids, those tend to be easier to identify the base because we remember we only have one of them. And then all of the lateral sides, the lateral faces are triangles. Triangular pyramids are the ones that sometimes are a little harder to see. When you have these three-dimensional figures, we have these things called cross sections. They are a two-dimensional slice of our three-dimensional figure. So if I'm looking at this rectangular prism, and it is a rectangular prism, maybe a square prism, don't necessarily know if that bottom side is a square or not, but if I take that and I slice it horizontally, so I take something and I slice it horizontally, and I look at this two-dimensional figure that we have here. So essentially we're taking these three-dimensional shapes and we're going back to two dimensions. I want to know what shape is that two-dimensional shape. That is a rectangle, or potentially a square if all my sides are equal to each other. Right here I have that square pyramid. This one's a little bit different. When I slice this, now I'm slicing it not quite vertically, but close to vertically. And you can see as I slice it, I don't have a square anymore, but rather I have this trapezoid shape. So depending on how you slice your figure, you can get different cross sections from different shapes. Because if I look at this this rectangular pyramid, these are both rectangular pyramids. This time I'm slicing them horizontally, and you can see my cross sections are these rectangles or these squares. So one way that I like to think about this is thinking about, and this may be just because I like to bake and I like to eat, but cakes. Pretend you made a pyramid-shaped cake. You made a rectangular pyramid cake, and you're slicing pieces for people, and you slice it this way, and you pull that out. You've got a trapezoid on the side now. That's your cross section. If I'm making, say, like this one, if I make a cylindrical cake, so I make a cake that looks like a tube, and I do a cross section sliced vertically, so that means I'm going down this way. I'm slicing it this way. Well, that shape, when I open up my cake, is now a rectangle. So my cross section would be a rectangle. So I'm looking at these cross sections. So I've got these 5 other shapes, and I want to slice them vertically, and I want to think, okay, what shape would I get? What would my cross section be if I sliced these vertically, if I sliced my cake? So if I look at this pentagonal prism, that's what this is right here. I want to slice this vertically. I slice it. I'm opening up this cake to share with people. I made it a rectangle. So this one also has a rectangular cross section. However, when I go to my pyramid, that's a little bit different. when I look at my pyramid, depending on how I slice it, if I slice it here, I now have a triangular cross section. So this time my cross section, not a trapezoid, but a triangle. And so what I want you to do is I want you to try and slice these vertically and figure out what their cross section is. So you can go ahead, you can pause the video for a little bit, give it your best shot. All right, so if I were to take my sphere, which is not a polyhedron, it's not a pyramid, not a prism, nothing, but if I were to slice it vertically, this is a little harder, whoops, sorry. So if I took this and I sliced it vertically, when I open it up, think about cutting an orange in half or an onion in half. If you were to slice that and you were to open it up, this is a little harder to see what your cross section is. Your cross section would be, if I can make this work for me, it would just be a circle. That's all it would be. It would just be a circle. If I slice that vertically, my cross section is a circle. This one is a special type of prism. It's a star prism, or if I were to count my sides, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. This is a decagon prism. That's the name of the shape. When I do my cross section, you can see my cross section is still going to be that star shape, right? My cross section is the star. Now this last one, this is a cylinder, just like our first one is a cylinder, but my cylinder is now laying on its side. It's like you took your water bottle, turned it on its side, or you've got one of those roll-up cakes. I don't remember what exactly they're called, but those cakes that you roll them up, sometimes ice cream cakes are made that way. And you want to take this and you want to slice this vertically. So you take that knife and you slice it straight down. That is going to create another circle as its cross section. So anytime you're doing a cross section parallel to a base, it's going to match that base shape. So we see that here with this cross section here. We saw it up here. All of these slices were made parallel to the rectangular base, so they are all rectangles. Now, one other way that we can think about our three-dimensional shapes is if we took those three-dimensional shapes and we unfolded them. If we thought of them as boxes and we unfolded them, we get something that's called a net. A net is a two-dimensional drawing that represents all faces of our polyhedron. So this first one here, I've got that pentagonal prism again. And if essentially what would happen is I slice all of these edges, take my knife and I slice all those edges, and I unfold, and I slice along the top here too, and I unfold it. I've got my two bases still, and they are all connected by those lateral rectangular faces. It is just unfolding of our prism. If I were to look over here, this is a hexagonal prism. This one unfolded slightly differently. All my rectangles are right next to each other instead of coming off of the pentagon or the hexagon, but it's still another representation. So this one, what happens is I sliced all of my hexagons except for one side, and then I did the same thing on the other hexagon, which the current drawing isn't easy to show that, but I sliced on all of them except for one side, and I unfolded the two hexagons and unrolled my rectangular sides. So there is a quick little video I want to show, and hopefully it'll work. Yep, okay, just wanted to make sure I was still recording. So if you see right here, we have a hexagonal prism, just like the one we looked at. And you can see this thing is unfolding sort of like that first pentagonal prism we had, where it's all those rectangular sides are coming off one of the bases and the other base is at the top. Here, let's rewind a little bit. So this one here This is a triangular pyramid. So I have my triangle base down at the bottom and all my other sides come up to a single point up at the top. If I were to unfold this, one way to unfold it, it looks like it's a parallelogram now. All these triangles come together and they create that parallelogram. But it's just the unfolding of that pyramid. See? Here, I actually don't like this one. We're going to get back to that in just a second. Here we have a cylinder. There we go. We have our cylinder. Unfold the top and the bottom and unwrap the sides, and you can see that the sides, what we would call the lateral face of our cylinder, is actually just a rectangle. Think about unwrapping wrapping paper. Wrapping paper is, bought as cylinders, but you unroll it and you make these rectangular pieces that you then cut and you wrap around your presents. So we have that cylinder that wraps together with two circles, one on the top, one on the bottom. Here we have our what's called a rectangular prism, potentially a square prism. And this one, when we unfold, we're going to come back to this next week. We've got a triangle in there that's going to become important later. But you can see it unfold, rotate a little bit. And here we've got our cone. Cone's got that circle base, comes up to the top. Not polyhedrons, but still shapes we're going to care about. Unrolls. When you unroll that cone side, we get that big pizza slice. We get a sector. That's going to become important when we talk about area of cones and volume of cones. And then last one here, we've got a cube, which we can unwrap. So we've got all of these different nets that we can see, all these wonderful things. I'm going to put this video up on Schoology if you want to see it, watch it later. But what we're going to do right now is we're going to match some nets to their solids. So I want you to take a minute. I want you to try and map 1, 2, 3, 4 with A, B, C, D and see if you can figure out which goes with which. You can pause the video and then come back and see if you're right. So number 1, that's our cylinder. That's going to be option C. We've got that rectangular that wraps around our two circles. Number 2 is not quite the same as that parallelogram that we looked at, but it is all those triangles together that would fold up and create B, the triangular pyramid. 3 is a rectangular pyramid. You can think about taking that pyramid and just unfolding all of the triangle sides. So 3 would be D. And then 4 is that cone. We've got that sector wrapping around our circle. So this next thing, we're going to do this in class. We've already done it or we're going to do it soon. But you've got some homework that's going to be due. Hopefully this made sense. If you have any questions, please let me know.